Hello friends, myself Dr. Dandakumar Ravole from College of Engineering Ambazugai is going to deal with fluid mechanics. So in previous class we have discussed some of the numericals on Buckingham's pi theorem. So today we are going to discuss about the dimensionless numbers. Now let us see what is a dimensionless number. The dimensionless number is nothing but a number obtained by the ratio of two kinds of force. Very first is it is obtained by inertia force, dividing it by some other forces, we get dimensionless numbers. So this inertia force is divided by viscous force, or it is divided by gravity force, or pressure force, or surface tension force, or elastic force. Then we get various kinds of the dimensionless numbers. So force divided by force. So unit of force is Newton. Newton divided by Newton gets cancelled, and the entity remains without any unit. So that's why we call it as a dimensionless. So now this dimensionless number is nothing but the ratio of one force to another force. Therefore, there is no unit for it. So as there is no unit, that means we call it as a dimensionless number. So it is dimensionless number or non-dimensional parameter. We call it as a dimensionless number or non-dimensional parameter. So these non-dimensional parameters are or dimensionless numbers are Reynolds number, then Froude's number, then Euler's number, Weber's number, and Mach number. So these are the 5 important dimensionless numbers that we are going to study today. One by one we will study these dimensionless numbers. So dimensionless number, Reynolds number Re, it is represented by Re. Froude's number is represented by Fe. Euler's number is represented by Eu. Weber's number is represented by We. Mach number is represented by Em. What this Reynolds number is? So Reynolds number is nothing but it is defined as the ratio of inertia force to viscous force. Inertia force of flowing fluid to the viscous force of the fluid is known as a what you say, a Reynolds number. So now let us see this Reynolds number Re is the ratio of inertia force to viscous force. Inertia force is represented by Fi, whereas viscous force is represented by Fv. So we will see this, what is inertia force and what is viscous force. So very first we will look at this inertia force. What is this inertia force? So inertia force is the product of mass and acceleration of fluid. So it is product of mass and acceleration of the fluid flowing fluid. So therefore this mass can be written as density into volume. So how we define density? Density is equal to mass per unit volume, mass divided by volume. So therefore mass is equal to density into volume. So we write this as mass is equal to density into volume, and this acceleration is written as rate of change of velocity, that is velocity divided by time, velocity per unit time, So acceleration is written as velocity per unit time, or change in the velocity per unit time, we can call. So this can be written as rho into volume divided by time. So we take time here into velocity. So now volume per unit time, is discharge Q, or that is we call as A into V. So substituting this volume per unit time as AV, rho into A into V. So this AV is area and V is velocity of fluid, into again velocity V. So this velocity is again written as V. So velocity V, and in place of this bracket we have written AV. So this is rho A V square. Rho A V square is nothing but the inertia force Fi. So inertia force Fi is equal to rho A V square. We call this as equation number 1. So now after that we'll move to the viscous force. So this viscous force Fv is nothing but the shear stress into area as we know that shear stress tau is equal to mu du by dy. So this force is equal to stress into area. As we have seen, always force per unit area, or shear stress or stress, is equal to force per unit area. Actually stress is the resistance force offered per unit area. So now shear stress is given by tau into area A. Now this shear stress tau is given by mu du by dy from this stir into area A. So now this mu du is change in velocity, we can call as a velocity, and dy is with respect to distance, that is length L into A. So this can be written as mu VA divided by L. So this is viscous force Fv. We call this as equation number 2. So now according to the equation number 1, or equation given equation for definition of Reynolds number, inertia force to viscous force. So Reynolds number is equal to inertia force divided by viscous force. So this can be written as inertia force is given here rho A V square, according to equation number 1, rho A V square. So according to this equation, inertia force is rho A V square divided by mu V A divided by L. So A gets cancelled. So V gets cancelled. So what is going to remain is rho LV divided by mu. So this is Reynolds number Re, which we have obtained here as rho LV divided by mu. Rho LV divided by mu. Now we can write this as VL divided by mu divided by rho. So rho which is in the numerator is transferred into the denominator of denominator. So VL divided by nu. So where nu is kinematic viscosity, which is the ratio of mu divided by rho. So Reynolds number is given by VL divided by nu, or this can be given as Reynolds number is given as V d divided by nu, or rho V d. From this, in place of L, d is written divided by nu. So in place of L, d is replaced for the flow through the pipe, for flow through the pipe. If flow takes place through the pipe, then this linear dimension length is converted to the diameter of a pipe. Hence Reynolds number for pipe or flow through pipe is rho Vd divided by mu, or Vd divided by nu. So this is one thing. Now coming to the Froude's number, it is defined as the square root of the ratio of inertia force to gravity force. It is defined as Fe is defined as square root of inertia force to the gravity force or this can be written as square root of Fi divided by Fg. So now we know Fi. Already we have obtained Fi in equation number 1 in previous case itself. So rho a v square. Fi is rho a v square. Fe, we call this as equation number, say in this term as equation number 37. Now up from equation number 1, Fi is equal to rho a v square, that already we have obtained in equation number 1. So now we will go for Fg. What is Fg? It is a gravity force So this gravity force is given by force due to gravity, which is nothing but mass into acceleration due to gravity So now already mass can be written as mass is equal to density into volume. Therefore this Fg can be written as mass is written as rho into volume into acceleration due to gravity. So now rho v is nothing but meter cube in meter cube, that is dimension length to the power of 3 into acceleration due to gravity is given as g. So now this can be written as rho L cube can be written as L square into L into g. This L square means area, or dimension area is given in meter square. So rho into A into L into g. So this is gravity force. We call this as equation number, say 4. So now we can define this Proud's number. Fe is equal to square root of Fi divided by Fg. Fi, that is square root of rho a v square from this equation number 1. Then Fg is equation number 4, from equation number 4 rho a l g, rho a l g. So rho gets cancelled, a gets cancelled, so we can write as a square root of v square divided by lg. Now taking the square root in the numerator, we get v divided by square root of lg is Proud's number that we obtained. Now coming to this next number, Euler's number. This is also defined as a square root of ratio of inertia force to the pressure force of a flowing fluid. So now this Euler's number Eu is given as square root of inertia force to the pressure force. So this is nothing but square root of Fi divided by Fp is Euler's number. So in numerator there is force, in denominator there is force, therefore units gets cancelled. So now we know inertia force, so pressure force Fp is nothing but intensity of pressure into area. It is given by intensity of pressure into area. So this is just how to remember is pressure is equal to force per unit area, that is pressure is equal to force per unit area, that is divided by area. Therefore pressure force F is equal to pressure into area, so this is given by this. So now this can be written as Fp is equal to P into A. So we call this as equation number say 5. So now F E is known. Now we have to find out Euler's number is equal to square root of inertia force Fi divided by Fe. So we know Fi, square root of Fi is rho a v square from equation number 1. Fe is, sorry, Euler's number. We have to go for Euler's number. So this we call as equation number 6. Now Euler's number U is equal to square root of inertia force divided by pressure force. Inertia force is known to us, that is rho a v square divided by P into A. So area gets cancelled. What is going to remain is square root of v square rho divided by P, or this can be written as square root of v square divided by P divided by rho, or this can be written as v divided by square root of P divided by rho. So this is Euler's number which we have obtained. So Euler's number is given by this. Now coming to next number, that is Weber's number. Again, it is defined as a square root of ratio of inertia force to the surface tension force. So Weber's number is represented by WE. WE is equal to square root of inertia force to the surface tension force that is nothing but square root of Fi divided by Fs. So now already we know Fi, inertia force. We must see this surface tension force. So the surface tension force Fs is given by the surface tension force is nothing but product of surface tension into surface tension into the length. So surface tension is given in newtons per meter, that is per unit length. So that is sigma into L. Now we call this as equation number 6, 7. So now we can see here Weber's number is given by WE is equal to square root of inertia force to the surface tension force, square root of Fi is rho a v square divided by Fs is sigma into L. So now this square root rho a v square, or area is nothing but length into length. We call this as length square into v square divided by sigma into L. So now we can cancel this L with one L in numerator. So we can get this as square root of rho L v square divided by sigma. Just here you can see area is written as length square. So this is kept here in place of area in this equation, or this can be written as V divided by square root of sigma divided by rho L. This is Weber's number. So this Weber's number is given by velocity divided by square root of surface tension divided by density into length. So this is dimensionless number. Next dimensionless number is matched number. This matched number is again defined as the square root of ratio of inertia force of the flowing fluid to elastic force. So again we can say this as matched number is defined as square root of inertia force divided by elastic force. So this is square root of inertia force is Fi and elastic force is Fe. So now inertia force is known to us, that is rho a v square. Now elastic force, What is this elastic force? Elastic force is nothing but the elastic stress per unit area, or the elastic stress into area. So this elastic stress is having elastic stress constant k into A. So this, say for example, elastic stress is given by a term k into area A, and this area is nothing but k into length square. So we call this as equation number 8. Now we can define this match number m is equal to square root of Fi divided by Fe. Fi is square root of rho A V square divided by K L square. Again we can write this rho A can be written as L square V square divided by K L square. L square gets cancelled. So we can take this V, square root of V square is V, and this rho, if we transfer into the denominator, it will be the denominator of denominator k divided by rho. So this is match number is given by V divided by square root of k divided by rho. So this k divided by rho match number square root of k divided by rho is substituted as c, velocity of sound in fluid, which is velocity of sound in fluid. Therefore this match number can be written as V divided by C. So match number is either given by V divided by square root of k divided by rho, or V divided by C, where C is the velocity of sound in fluid. So this is how we have discussed about the dimensionless numbers, which are of very much use to decide the fluid in motion or to decide the fluid properties. These dimensionless numbers have got their own significance. So today we stop here, and in next class we'll start with new unit, last unit.